Hi everyone, welcome back to the coding series. Today's problem is kth missing positive number. Let's understand the problem statement. Given an array of positive integers sorted in strictly increasing order and integer k, return the kth positive integer that is missing from this array. Let's understand that with the example. I am considering the same example that was mentioned here. So array equal to 2, 3, 4, 7, 11 and given k equal to 5. Okay, that means you have to return the fifth missing number. Okay, so since they have mentioned, okay, so before to that, what and all are positive numbers? Okay, so positive numbers means that will lie between 1 and n if there are n positive integers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and so on, right? So this is the superset, right? Okay. So all positive integers between 1 and n. Okay. Now when you compare these two, what and all are missing numbers? So missing numbers equal to, so 1 is missing, 5 is missing, 6 is missing, and then 8, 9, 10, and then 12, 13 and so on. Okay. Since you have to return fifth missing number, so 1, 2, 3, 4, 5. Okay, so this is the fifth missing number. So output is 9. So in that way you have to calculate. Okay, now let's take second example 1, 2, 3, 4 and given k equal to 2. That means you have to return the second missing number. Okay, if you compare these two, what and all are missing? Missing is 5, 6, 7, 8 and so on, right? So since you have to return second missing number, that will be 6. So output here is 6. Okay. Now let's see how we can solve this. Okay. Before to that, okay. So what and all positive numbers? Positive numbers, as I mentioned, that will be 1 between 1 to n. So 1, 2, 3, 4, 5, 6 and so on till n. Okay. So for this number, okay, can I write this number as, since index will be 0, 1, 2, 3 and so on, can I write this number as I plus 1? That means array of I equal to I plus 1. Let's see. Since I equal to 0, so array of 0, 0 plus 1, that is 1. So see, we have got 1. Okay. Now let's check for second element, array of 1. Array of 1 is 1 plus 1, that is 1 plus 1, that is 2. See, 2. Similarly, we will check array of 4. Okay, that is 4 plus 1, 5. See, so now, okay, keep this in mind. Okay, now given array is 2, 3, 4, 7 and 11. Okay, now we have to calculate for each element how many missing numbers are there. Okay, before to this, you have to calculate missing numbers before this element. Okay, so for that, count of missing numbers for each element in an array. Okay, for 2, okay, how many missing numbers? So we have only 1. Similarly for 3, how many missing numbers? 1. For similarly for 4, missing numbers is 1. For 7, okay, till 4 missing numbers is 1. So 5, 6, 7. These two are missing from this, right? So 1 plus 2, 3. Similarly for 11, okay, if you take 8, 9, 10 and 11. So till 7, we got 3 missing numbers. So then next missing numbers are 8, 9, 10. These are not present in this array, right? So 3 plus 3, 6. Okay. Now, how to derive this? Can I write array of I minus I plus 1? Because this array is the actual element here. Okay. But at 0 index, okay, we should have 1. Okay. That we have derived like this, I plus 1. Okay. So, to calculate missing numbers, the present element, okay, minus the actual element. If I do that, we can get the, here present element is 2, okay, but actual element uh, should form according to I plus 1, right? So here actual element is I plus 1, okay. So if you subtract present minus the actual element, then you will get how many missing numbers are before to this. Let's see that. Here I equal to 0. Here I equal to 0. Okay. Let's calculate for this. Okay. So array of 0, that is 2, minus 0 plus 1, 1. That is 2 minus 1, 1. Okay. Now let's calculate for 7. Okay. Same using this formula. So array of 3. Array of 3, 0, 1, 2, 3. Array of 3 is 7. Minus 3 plus 1, 4. See, we have got. So for calculating count of missing numbers, can I write array of I minus I plus 1? Okay, keep this in mind. Now we will solve this problem using binary search. Okay. So if you guys don't know about the binary search, in my earlier videos I have explained the binary search. I will add those links in the description. You guys can check it out. So for binary search, we should have low and high, right? We should have low and high. So low will be pointing, in most of the cases, low will be pointing to the first index, so that is 0, and high will be pointing at the last index, that is n minus 1. Let's take the example 2, 3, 4, 7 and 11. Okay. Now, okay. So for 2, 3, 4, 7, 11, what all and all the missing numbers before this, like count of missing numbers, number of missing numbers before this each element. So 1, 1, 1, 3 and then 6. Okay. Now for low less than or equal to high, okay, for low less than or equal to high, you have to calculate first mid, right? Mid is equals to low plus high by 2. Okay. Now let's write all the positive numbers. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I will consider the example 2, 3, 4, 7, 10 and 11. Okay. So for 10, how many missing numbers? So that will be 8 and 9. So that will be 5. Here also 5. Okay. Let's write that properly. properly. So for 3, 7, 3, for 10, so 8, 9, 2 extra, so 5, and for 11 also 5. Okay, now, okay, now our first check should be, okay, here till 7, how many missing numbers? 3 missing numbers, okay, but given k equal to 5, that means you have to return the fifth missing number, okay. So till 7, okay, you have only 3 missing numbers, okay. So in that case our answer will not be present before this, right? Like before this, that means before this, because till 7 we got only 3 missing numbers, okay. Now you have to find the first index where our count of missing numbers is greater than or equal to k. Okay, so to find the number of missing numbers, can I write array of if array of, sorry, here it is mid, because you have to, since we got the mid value, so array of, so if array of mid minus mid plus 1, I am replacing I with mid, is if this number is greater than or equal to, sorry, greater than or equal to k, okay. Now what we have to do, else part, else what we have to do, we will write, okay, and what you have to return at the end, we will see that, okay. So as I mentioned, 3 means, so we can say our answer, because you have to return the fifth missing, but here we have only 3 missing till here, so you have to find the first index here where our this number array of this count of missing numbers should be greater than or equal to 5. So here k equal to 5, this is one index and this is one index, but when you compare these two, what is the first index? First index is this one, okay. First index number is 10, but first index is 0, 1, 2, 3, 4. So here index is equals to 4, okay, right? You have to find the first index where our, okay, where our missing numbers are greater than or equal to k. So if you find this one, okay, for suppose we got the mid as, for suppose we got the mid as what, 5, okay, index 5, okay, you will calculate this, okay. Then so index 5 means 11, right? So you will calculate, and what you have to do, so since you have to find the first index, our first index will be 10, okay, but here we got index as 5. When you calculated mid, we got the index as 5, since and we satisfied this condition, okay. This condition got satisfied, but you have to return the first index, not you have to return the first index, you have to calculate the first index, okay. So to that, can I move my pointer, since my pointer is since high pointer is here, so after this, if there are some elements, okay, if there are some numbers like some 14, something like that, this missing count will get increased, right? This missing count will get increased, okay. So you, even if you calculate these right side elements, it's of no use, because for 11 only you got the missing number is greater than or equal to 5, okay. Even after you check these elements, it's of no use, okay, since you have to get the first index where our this value is greater than, or where our count of missing numbers are greater than or equal to k, okay. So can I move my pointer to I equal to mid minus 1, because we have calculated already mid, it's, so if you, it's of no use again if you move our pointer to mid minus 1, In that way, you will eliminate, or in that way, if you take 2, 3, 4, 7, 10 and 11, initially our high pointer is here. So if you move our high pointer to this one, that is because mid will be here. Okay, so if so mid is here and high is also here. Okay, first suppose. Okay, now you have to move your high pointer, and there are some elements if you think. Okay, so if you are moving our high pointer to here, in that way you will eliminate the right side, because you will be checking between low and high. Okay, so high equal to mid minus 1. In that way you will eliminate the right side elements after this mid. Okay, like right side elements to the mid you will eliminate, so you will check only left side elements to the mid. Okay, now if that condition is not satisfied, that means you have to move your low to mid plus 1. Okay, okay, now since, okay, now let's see. Okay, let's compare this 2, 3, 4, 7, 10 and 11. Okay, now I will write all the positive numbers 1, 2, 3, 4, 5 and 6, 7, 8, okay, 9, 10, 11. Okay, now this number is not there. Okay, I will write it as missing number. Okay, and this one is present. I will write as present. This 3 is also present. Okay, present. Okay, 4 present, but 5 is missing, and 5 is missing, and here 6 is also missing, and 7 is present, 8 missing, 9 is also missing, 10 is present, and here what, this is also present. Okay, so when you do this calculation, okay, when you iterate this, you will end up your low pointer here. Okay, low pointer, that is index, if you see here 0, 1, 2, 3, 4. Okay, that is 4. Index is equal to 4. If you do this entire iteration, you will end up our low pointer here. Okay, that means, so okay, now 2, 3, 4, 7, 10. Okay, one missing number, one missing number, one missing number, but here 3, but here 5 missing numbers. Can I say my answer will lie in between these two? Yes, right? It will lie in these two. Okay, this 7 and 10. Okay, now, so since our index, our low pointer is pointing here, can I say for my answer, so how many what numbers are before to this? There are 4 numbers. Before 10, how many numbers? There are 4. Okay, so 4, if you take 2, 3, 4, 7 and 10. Okay, since our low pointer, after you do all this iteration, our low pointer will be here. Okay, because this is the first index where our missing count is greater than or equal to 5. Okay, 11 is also missing, 11 also satisfies the same condition. Here also count is greater than or equal to 5, but you have to find the first index, so that will be here. Okay, so since our answer also will lie in between these two, how many numbers are before to this? There are 4 numbers. Okay, so here index is also 4. Can I say my this low index as, okay, since our answer also lie between in these two, okay, how many numbers are missing in between these two? 8 and 9 are missing. Okay, only between 7 and 10. Okay, so how many numbers are before to this index number? how many numbers? There are four numbers are okay, four numbers are before to this, right? So how many numbers are before to this 10? There are four numbers. Okay, four numbers. So this index also denotes like that only, right? That means this index is 10. That means there are four numbers before to that. Okay. Now, since you have to calculate, okay, since you have to calculate the fifth missing number, okay. Now remember, okay. Here how many missing numbers? 1, 2, 3, 4. Okay. How many? 1, 2, 3, 4 and 5. Okay, total 5 missing numbers. And these present numbers, how many present numbers we have? Present numbers 4. That is denoting this one. Yes, right? So how many missing numbers total? 1, 2, 3, 4, 5. So our answer will be written. So here if you write how many missing numbers? 5 missing numbers plus what is this low value? Low value is 4. So answer is equals to low plus k. Answer equal to low plus k. Okay. See, if we have 5 missing numbers and 4 what? 5 missing numbers. Okay. 5 missing numbers and how many present numbers? Present are 1, 2, 3, 4. 4 plus 5 gives the actual number that is missing. Okay, at the fifth missing number. So here if you see the fifth missing number, here is 1, 2, 3, 4, 5. Fifth missing number is 9. So we have got the value also, answer is also 9. Okay, simple. What? First you have to take low and high pointers and you have to iterate till low less than or equal to high. First calculate mid and first find the first index as I mentioned. Okay, here 10 and 11 both satisfies this condition, but you have to find the first index. In that way you can see how many numbers are before to this. Okay, that will give the what that will give the value. So if you add that value to the missing, okay, for 5 if you take how many elements are before to this, sorry, for 11 how many numbers are before to this? There are 5 numbers, 1, 2, 3, 4, 5. Okay, if you return that low, sorry, if you if you keep that, if you here if you will return low plus k, because low denotes the first index of the where this condition satisfied. If you take this index, then how many numbers? 5 plus 5, 10. But our answer is 9, right? Our answer is 9. Our answer is 9. Okay, our answer is 9. So you have to return the first index. Okay, so in that way, you to get the first index, you have to move these pointers to high equal to mid minus 1 and low equal to mid plus 1. Okay, and you have to return low plus k. Okay, so if you think that about the time complexity and space complexity, say space complexity is how many variables we have taken. So extra variables 1, 2, 3, only 3. So O of 1 plus O of 1 plus O of 1, that is O of 1. Okay, space complexity is O of 1. Okay, now time complexity. Okay, since we are iterating till low to high, okay, so for binary search, what is the time complexity? It is O of log n. Okay, now let's code this. I have took low pointer and high pointer is the denoting at the last index. Now low less than or equal to high. finding the mid and checking the missing count. Okay, if missing count is greater than, then I am moving my high pointer, else moving my low pointer. And after you find the, in this way you will get the first index where your missing count is greater than or equal to 5. So if you take that value plus how many missing numbers, it will give the total, sorry, actual missing number, which is lying at the kth position. Okay, now let's submit this. All test cases are passed. That's all for today's guys. If you guys have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.